Now talking about examples. So how can you use the Sensoterra index on your daily basis irrigation events? So starting with peat. So peat soils, how the soil moisture measurements will show. Uh, so first of all, we have the original scale graph for peat soils. So if you look at the vertical axis, you have the soil moisture percentage from 0 to 100. So we can have an idea that for peat soils, they go from thresholds from 25 or a bit below 25% to, let's say, 70%. So when reading soil moisture, you will see that your sensors, they will present peaks. These peaks represent, they indicate the soil moisture levels from your soil. So the maximum peak will represent the higher water levels from your specific soil. So these higher water events, they can be understood as or caused by, let's say, by irrigation or by rainfall. So with a higher irrigation regime, you have higher soil moisture values, or with a heavy rainfall, you have higher soil moisture levels. And the tendency is to go down and then a peak again. So with the peaks throughout time, so in the horizontal axis, you have time. So this graph is indicating soil moisture per time. You will see the behavior of your soil. So, for example, this peat soils, you have setting points from 25 to, let's say, until 70% for the original scale. Now, comparing the original scale to the Sensoterra index in red. So this is indicating that when you use Sensoterra index, it becomes easier. So instead of using percentages to understand about your soil moisture, you're just using a scale from 0 to 10. So you have scores within this scale from 0 to 10 that you can keep your thresholds. So this makes it easier for you on a daily basis to make your irrigation decisions. We make it easier. So we give you the information so you don't have to think or stress about this. So let's see, how can you interpret this with the Sensoterra index? So from the scale 0 to 10, you can see that the middle part is the productive zone or the healthy zone that we want to keep our soils at. In this case, peat soils. So you see that from 3.3 to 6.6 is the healthy zone that you want to maintain when using the Sensoterra index. Now for sandy soils. When looking at this graph, you already see that sandy soils, they have the soil moisture in sandy soils, they have a different behavior than peat soils. You see lower soil moisture percent values. And this, again, once again, we see this for sand because sandy soils, they tend to present lower water holding capacity. So with a lower water holding capacity, less water will be retained in the soil and more water will be drained from the soil. So you naturally work with lower soil moisture percentages. So in this case, again, the vertical axis, we have the soil moisture from 0 to 100%, and horizontal axis, you have time. And your threshold would be there from 2 to maximum 20, maximum 30, let's say. With the SensoterraIndex, you see the difference between the original scale and the SensoterraIndex. So in this case, for sandy soils, when using SensoterraIndex, your life becomes even more, even easier, if we can say like that, because for sandy soils, it becomes a bit more tricky to understand the irrigation necessities on your crop. So you have to keep close eyes to keep a close look at the necessities of your soil. So you can see that this, when using the SensoterraIndex for sandy soils, you have a better context vision, if we can say like that, because you know that your thresholds, they will be higher than the original scale. So let's have a look at the too dry, too wet, and healthy zone. So you see that your healthy zone is going from 3.3 to 6.6, but that you constantly need to irrigate more than peat soils, more than peat soils, because peat soils, they have a higher water holding capacity, so they retain more water in the soil. Now going to clay soils. So you see that clay soils, the soil moisture values, they tend to be more stable. So they don't show crystal clear peaks as we saw for peat and as we saw for sandy soils. It tends to be more stable. So for the original scale, we see that goes from let's say 45 to 50, 52%. So this is the threshold that we see for the original scale. When using SensoterraIndex, you know that you need to keep it a bit higher than the original scale. So your thresholds for peat, they will go from, let's see, here, the productive zone, they will go again from 3.3 to 6.6, but once again, using the SensoterraIndex can make it easier, because then you look at scores. So from for the productive zone, you have the thresholds that you need to follow. Now comparing all soil types together. You have peat, sand, and clay. So looking at this graph, you already see that peat, sand, and clay, as we talked before, they are soil textures. They are different soil textures, and they have different physical conditions. And these physical conditions will reflect on their necessity for irrigation. So these physical conditions will indicate porosity, will indicate soil particle sizes, and this will reflect on the necessity for more or less water, how much you should irrigate based on the soil texture. So we see different behaviors for sand, peat, and clay. once again, when putting all together with the Sensoterra index, they will show different reactions. And these are the reactions that you need to follow when making your irrigation decisions. That's it. This is what I had to talk for this presentation. In case you have any questions, please email me at caroline.arab@sensoterra.com. I hope you liked the video. More videos are about to come. And yes, when using the Sensoterra sensors, we want to give you the highest knowledge for you to easily interpret your data and make the right decisions in the field. So yes, please have a look at the other videos as well. So this is what I had to say today. Thank you. Bye.